we skipped 5-3 because we wanted to do all the geometry ones first. We have estimated areas under a curve using rectangles, using midpoints, LRAMs, RRAMs, and now we're going to fit a trapezoid under the curve, and we are using y equals x squared. Okay, we are going to divide this into four rectangles, not rectangles, trapezoids, and let's keep the bases the same. And we're going to integrate, because that's what that little integral says. I want the area from 1 to 2, from x equals 1 to x equals 2 under the curve. Well, what's f of x? What's my function? X squared. Okay? And we're going to talk about, as we do the problem, what would be expected on the exam, on the AP exam. What do you have to do to get your points? Okay, so I should see all phones put away. And we're going to work on this problem. I know it's kind of a crazy day, but that's okay. I'm not going to do this to scale because I don't have that much space. So I'm going to pretend that this is 1 and then this is 2. And we are going to divide this into 4 equal regions. So ignore the tick marks on the bottom. Okay, Samuel? Samuel? Math. We're going to divide it into 4 trapezoids with equal size bases. So where is this? Where's halfway? Okay, 1 1/2, or I like to write it as 3/2, just to make the arithmetic easier. Is that okay, guys? Okay. And then I'm going to divide again. I want 4 equal parts here. So where's that? Oh, I'm not doing trapezoid just yet. I'm just dividing the bases, the base of my figure. Now, this is not going to be the base of your trapezoid. It's going to be the height. Where's this one? 1 1/4 or 5/4. So where's this one? 1 3/4. That's right, or 7/4. And now we're going to fit in trapezoids. Well, they're not going to be inside, are they? Well, let's draw one. We'll zoom in on it. You can see this trapezoid's outside the curve, so that's an overestimate. But could you have had this one? And then this trapezoid would be an underestimate. So to figure it out, I just draw the pictures. I haven't memorized it yet, even though I've been doing this for 20-some years. Okay, so we're going to put trapezoids in here, and we're going to use 4 trapezoids with the same height, because this is the trapezoid. So let me draw it. I'm going to pull it out. And I'm going to rotate it. And this is the height of the trapezoid. Well, guess what this length is? It's this length. It's the change in x. And how big is that? 1/4. Does that make sense? You're going to take this width, okay, guys, 2 minus 1, and divide into 4 equal parts. So it's 1/4. And this is base 1, and this is base 2. So this is a base. How am I finding the base? It's the function. It's f of x at that particular point. And then here's the other base. Okay, so are we ready to do this? And then we'll see how it compares to the actual value. And we could do LRAM and RRAM, but we won't do that today. So I'm going to find the area of this first trapezoid. So it's 1/2 the height times the sum of the bases. That's the formula. So Ben, what's the height? That's this length, 1/4. So it's times 1/4. And then I'm going to do this generically. I could figure out the number for the height, but let's not. Let's just say, I'm not sorry, not height. base. This base is f of what? F of x evaluated where? At 1. And if you don't understand something, you just have to tell me, okay? It's okay. Plus, and then we're going to notice some interesting things, at least I think they're interesting. Then this is f of what? 5/4. I prefer the fractions because then I don't have to use a calculator. That's the first one. Okay? That's this one. Now we're going to do this again. And we're going to find the area of this trapezoid. What's the height of the trapezoid still? Hasn't changed. How wide is that? Let's see. We set it right over here. 1/4. Okay, so I'm going to use black ink for this one. And I'm going to do it on separate lines. It's 1/2 the height, which is still 1/4. We kept it the same. You don't have to keep it the same. Read the problems carefully on the exam. They might change it. And then it's going to be 1/2 of 5/4 plus f of, that's this base here. I want to call it, it's the height of the curve, but it's the base of the trapezoid. So it's f of, what was it? 3/2. Notice anything interesting? What about this and that? It's the same, isn't it? Is that going to happen throughout the problem? Now, there is a formula. I'm not giving you the formula for the trapezoidal rule because students who wrote that down on the exam got nothing. They're going to give you a finite number of trapezoids, probably no more than 4, probably only 3. And that's all you do is do exactly what I'm doing. Am I doing any calculus? No. Finding areas, I'm doing geometry, finding areas of trapezoids. So let's go to a different color. And let's look at this one right here. Well, guess how big the height is? It's still 1/4, right? Right, Declan? Yep. Still 1/4. And the 1/2 is still there. So it's 1/2 times 1/4. And what's the height of the function or the base, this base of the trapezoid? It's f of 3/2. Now, it doesn't matter what the function is. What I'm doing is just working it out. And if you get all this part right, you'll get at least 1 point. Plus, we're not done though. And what's the other base? F of 7/4. Okay. And the last one, I'm going to do the last trapezoid, which is this one. Something interesting there, too. So the height, excuse me, is still the same. And the base, without even looking at the picture, is what? F of 7/4. Did you notice that these are the same? And these are going to be the same. I can't highlight it because it's too dark. Plus f of, what was the last one? 2. So the first and the last ones are all by themselves, but all the ones in between are used for trapezoids on the left and the trapezoids on the right, so they're doubled. So I could clean this up nicely. Pardon? I could. I'm just going to be a little more sequential. Hard as that is for me. It's 1/8. I'm going to add them all up, and I'm going to factor out 1/8 because that's the same in all of these, right? So it's f of 1 plus, then it's f of, I don't know. Got to look at it. 5/4, and how many of those are there? 2. Yeah. Plus, but you don't even have to do that. You can just do brute force, just plug in the numbers, and don't have to add it. You're done. Well, we're going to add it because we want to compare it with the actual answer. And let's see, I have 2 of the 5/4, and how many of the 3/2? 2 of those. How many of the f of 7/4? 2 plus f of 2. So the first and last will not have 2's. They'll be just 1's. And all the middle ones will be double. Now, if you want to memorize that, that's fine. But some students on the exam wrote down the trapezoidal formula in general, and we gave them nothing. You actually have to find the area. So, and remember what f of x was? What was the function? X squared. So now we have to substitute the numbers in there. So it's 1/8. F of 1 is 1 squared plus 2. And I'm going to put in 5/4. And guess what I'm going to do with 5/4? I'm going to square it. Yes. I'm going to do the points in a second. I'll show you the points. Then this is 3/2. And pay attention to what you're writing, not like what I did in the last class. Plus 2 times 7/4 squared plus 2 squared. You will get all your points with just that one line. 2 points. There's 1 point for evidence of the trapezoidal rule. And I could have written any one of these 3 lines to get my first point. And then when you substitute in, you get your second point, and your second point goes away if you evaluate it wrong. Sorry to tell you that, but that's the way it is. So when you get here, stop. But we want to see how good this is. There were only 4 trapezoids under there. That's not very many, really. So let's go ahead and figure this out. You guys love your calculators, but I don't. This is 2 times 25 16. When technology doesn't work, it gets me in trouble, so I better be able to do it by hand. So the first hour of the day, I teach how to use the graphing calculator without the graphing calculator up and over it. It was challenging. It's the only time I ever used a graphing calculator. So it's 2 times what? Square it. 9/4 plus 2 times 49. No, square it. 16. And see, that's where you can make the mistake. It's easy to do. Okay, Stephen? Put that away, please. No, away. Plus, and what's this going to give you? 4. Well, I do the easy things first. I don't know if we want to reduce it, because I've already done the problem. It's probably better to not reduce it. Normally I would. It's 1/8. Let's do the whole numbers. 1 and 4 gives you what? 5. This is 50/16. Now that's 18/4. How many 16ths? I have 18/4, right? I want to get to 16ths. So multiply by 4/4. Does that work? 36 times 2 is 72. We have to have common denominators. Plus 2 times 49. 98. 16ths. And then we have to add all that up. It is a big number, but what's 8 and 2? 10. Now you're not carrying 1. We say carry 1, but we're adding 10. 6, 13. 13 and 9 is 22. Yeah, we reduced it. It was probably a little easier reducing, but that's okay. 5 plus 220 over 16. Does 4 divide in evenly? If I go 4 into 220, do you remember this? Oh, division. Okay. That's okay. We're going to use the calculator in a moment anyway. So it's 5 plus 55/4. Do you want to change the 5 to 4? Right. So that ends up, I'm losing here, 1/8. That's 20 plus 55 is 75 fourths. No, you'd be given a calculator here. You don't have to do any of this. I wouldn't even do it at all. So this would be 75 over 16. How many times does 16 go in there? Oh, not 16, 32. I was so proud of myself for not making a mistake. Approximately twice, right? Do you know how to do that division? How many times is 2 times 32? 64. About how many times? 3. So you get about 2.3. But well, let's use our calculator. Now, I had to do this twice in the last class because not everybody has pretty print. People had pretty print, wanted to use it as pretty print. So, um, okay, first thing we had was 75. Let me get rid of some stuff. There we go. First thing we had was 75 over 32. Let's find out how big that is. You have to have an 84 calculator. Okay, that's my answer for that. And then you just need somebody who has the new operating system, which would be me, or anybody else, and then link them. Now, you guys, if you want to get the new operating system, because it does fractions, it does change a base, so if you're on the ACT, that would be kind of nice. You need to get the new operating system, but it takes me about 10 minutes per calculator. It takes a while to do it. So don't put it off to the end, okay? Now, you guys, let's do the old-fashioned one. And by the way, listen carefully. If you wanted to buy a new 84 calculator, if I wanted to get a new calculator, I would either get the Inspire CAS. But guess what? You can't use that CAS on the MCAs anymore. They just changed that. Okay? Or if you're juniors, you have to take the MCAs. Or you get the new 84 color. 84 is now on a color screen and it has a rechargeable battery. So you don't need to buy batteries. Yes. It's the CAS part that's not allowed. Can't use the CAS on ACT, but you can on the SAT. And it makes a difference. It does make a difference on the SAT. Now once you use it. Okay, shh, guys, let's do this. Do you remember how to do it? You go to math. Does anybody remember the number? I didn't want to graph it. Math 9. Okay, shh, guys, write down. Then we're going to take our function. It's so easy. Let's just type in x squared. That does either an integral or derivative. I can't tell unless I look at it. Comma, and where are we integrate from? 1, comma, 2. And it's so forgiving. I don't need these parentheses, but I'm going to put them because I like it correct. And there it is. 4 trapezoids gave me 2.333. Not bad. If you write it, what you write on a test with a calculator, if they ask you to do this, would be the integral from 1 to 2 of x squared or f of x. If f of x is defined, you may use f of x instead of writing the actual function, because it's not going to be simple like x squared. Now, do you want to see it with pretty print? Yeah. Oh, you will see. So I'm going to go to mode. Now, this is the new operating system, and it does fractions. Well, that's what we call it. Notice that everything I did is gone. Now, if I go to math 9, I get the integral the way they want to see it on the exam. And this is from 1 to 2. And then I go over. That's x squared, or I pick y1, however I want to enter it. I would usually like to put it in y1. It's just easier with respect to x. That's all it does. So it looks, pardon? You have to have an 84. And there it is. Now, here's the other nice thing about the new operating system. Besides the fractions, I can go alpha, and I press the window key, and I can get FNINT right there. I can also do, okay, you guys, alpha, and I can do fractions. So I can add 1/2 plus, whoops, not the right place, got to go up, delete. Okay, then I got to go back up and go to the right. There we go. It's not so easy. And then I go alpha, but I don't even have to put it into fraction mode to do that. It does. But I can do it this way. I can do 1 divided by 2 plus 3 divided by 4. And it's still, oh, I don't have it set for fractions. But you can go to mode and do fractions. Or I can just take this and press enter and go alpha. And I want to change that to a fraction. And I'd like to have it, decimal fraction is 4. And then I can go alpha. And then I can change it to a mixed number, which is 3. 1, 1, 4. So it's very nice. You have to go to calculus. Yes. So when you go to the menu, you have algebra, numbers. Go into calculus, and integral will be there. You can type in FNINT, and that will also work, I believe, on an Inspire. Okay. We have another activity to do. And are there questions on the trapezoids? You really need to do the problems so that you feel comfortable. You will have a Riemann sum. It could be rectangles or it could be trapezoid. That's a guarantee. I've never seen that not on the exam. Okay, so I'm going to bring up the other smartboard and give you the other handout. And we're going to do this one. Well, it's 10 minutes. Okay, you guys. No, it's the pizza. Okay. Okay, guys. What does this mean? Now the question came up, what does a dx represent? Okay, this is the base of your rectangle, and this is the height of your rectangle, and this says find the signed areas of all the rectangles under that curve. So guess what I can do with the 4? What do you think I can do with the 4? You think I can pull it out like I did with derivatives? So it's 4 times the signed area from 1 to 4 of f of x dx. And they gave that to me. It's right here. Okay, guys? Yeah. Now, if this were a free response problem, I would show my work. I would show that I pulled the 4 out. I mean, I don't want you to get into so many details. You spend too much time with that, but you need to show the basics of what you're doing. So this one is the area from 1 to 4 of G, I'm going to be sloppy here, minus the area from 1 to 4 of f of x. What's the area of G? It's up here. I don't know what the function is, but I can find these values. So what's the area of G? We're doing B. It's 2 minus the area from 1 to 4 of f, which is, so the answer is -5. Remember, an integral is a signed area. And I've already had some questions, but what if you have an odd function? Because it is a signed area, these are equal values but opposite in sign. So this integral from minus a to a of this function is 0. Well, tell me what C is. It's given up here. You have homework problems just like it. Should be in 5 too. So I should get 5-2 either today or tomorrow, but you need to finish it. Because I was lazy. This is because it formally I should have written it this. You'll find that you're going to do that on the exam because of time. They'll give you credit for this. Okay, do we have an answer for C? It's subtraction. Oh, we have to split this. Let's pull the 8 out. minus, so this is 8 times 7 minus 7 times what? 2. Oh, it might be that big. 56 minus 14 is 42. What's the answer to D? Negative 7. Okay. You have problems in your homework. We're just a little behind on that. But now, you don't have the picture, so guess what? You got to draw the picture. Yes. Can I change it yet? This is just an odd function. Here's the picture for the second one. Okay, Jack. How do you do it? It's 8 times the integral of f from 1 to 5. There you go. Mhm. I don't care how you break this up. I want to go from 0 to 2. Now, what is this up here? It's a semicircle. What's the radius?
R equals
1.
Where'd you get that from?
Yes. It was omitted on your sheet. Sorry. So if I just want the area from 0 to 2, how do you want to divide this up?
Wait, are all those like solid lines? What's solid?
It doesn't matter because for a function to be integrable, there can be a finite number of holes in the graph. Doesn't have to be a function, but this is. What's the area of that shaded rectangle? What's the base? 2. What's the height? So it's 6 plus, then you need this little part up here. What? It's 1/4 pi r squared. It's a weird answer. You will find weird answers on the exam. So I want you to try it. Oh. So what about 1 to 3?
Oh,
Yeah. I break my arm again. I'm not going to be happy. There. What do you got there? You got a rectangle? 1/2 a circle. Do you guys agree with me on B?
see, he can't do it either. No one can do it.
Okay, Jack, how are we going to find this area of everything here?
The trapezoid.
No.
The area.
Well, you have a rectangle from here, which is how big? You could. Okay, let's do a trapezoid. It's 1/2. What's the height of my trapezoid? And then you add the bases. So we did the trapezoid there.
And then we added the semicircle plus. Look at that.
So that's 12 plus 1/2 of pi. Can you guys do the arithmetic that fast? That's 8 divided by 2 is 4. 4 times 3 is 12. Now, what's the easy way to do the last one? Find the area from 0 to 5, everything, and subtract off the area from 0 to 1. Does that make sense? Oh, I'm recording. Okay.
Miss Jean, you said you broke your arm in class before.
No, I said I've broken my arm.
Oh.
I don't want to break it again.
How'd you break it?
I fell.
How'd you
Okay,
fall?
so you could find this entire area and subtract off this area from 0 to 1. So it's 12 plus 1 half pi minus that area, which is 1 times 3. So it's 9 plus a half of pi. Now you should know how to do the end of 5 too. So if you have it done today and you want to turn it in, fine. If it's not done, you want to turn it to me tomorrow, that's fine as well.